Effect of the type of plant on oxygen levels. Jordanos Mogus, West Potomac High School. Research question. Through previous research, it's known that dead zones are created when an area receives too many nutrients. Once a system of eutrophication takes place, the ecosystem is no longer able to function because there's not enough oxygen in the water for the plants or animals. Dead zones are not only harmful to these ecosystems, they hurt everybody by contributing to climate change. As part of a never-ending cycle, they aren't only causing climate change, they're also caused by climate change. As more realize this, farmers have been decreasing their amounts of fertilizer that gets into water systems, helping with the decrease of dead zones. This means that immediate action needs to be taken to prevent any recovering dead zones from returning to their previous states. The purpose of this experiment is to figure out what kinds of plants are the best for helping recovering dead zones. When there is a smaller amount of fertilizer and excess nutrients in the water, ecosystems are in a fragile state as they recover. This is the perfect time for human intervention. Adding aquatic plants to these recovering ecosystems would be a good way to increase the DO levels in a sustainable way. This leaves the question of which plants are the best to plant to increase DO levels the most sustainably. This is where my experiment comes in. My research question is, what kind of plants, aquatic, semi-aquatic, or floating, are the best at creating dissolved oxygen? My hypothesis is if a plant is completely underwater, then it will produce more oxygen because they are releasing all of the oxygen produced through photosynthesis directly and solely into the water. Methodology and procedures. I put 3 kinds of plants, true aquatic, semi-aquatic, and floating, into glass jars while being weighed down by rocks. Before adding any water, I took some of the filtered water and used DO tablets to figure out the starting point of the DO. After adding in the water, I left them alone for 3 days to do photosynthesis. At the end of this time period, I took samples from the water from each jar and used DO tablets to find the endpoint of the DO for each plant. I also remeasured the DO level of the same filtered water. My control group was the filtered water because it allowed me to see the result of the different plants compared to what happened without the plants. The steps that I went through are listed on this slide. Here you can see the plants once I'd set up my experiment. The image on the far left are Cardinalis plants, the middle ones are Lucky Bamboo, and on the right is a Cyperus helferi. Results. My experiment proved my hypothesis right. As I predicted, the final DO levels of the different plants shows that oxygen is released more directly and quickly into the water by fully submerged plants, with the true aquatic plants having an average of 5.67 parts per million, or ppm. The semi-aquatic and floating plants each had an average DO level of 5.34 ppm. This means that while all of the plants have made the DO levels increase by more than 2 ppm, with the true aquatic plants reaching an increase of almost 4, the filtered water, which was the constant, saw a decrease from its starting point at 3 ppm to 2 ppm. Interpretation. The filtered water that was tested at the end of the experiment had a lower DO level than at the starting point. This is likely due to the fact that when drinking water is left alone, it loses DO until it's moved around. An example of this is when you leave a glass of water by your bed for a few days and it has a flat taste. The final DO levels of the different plants shows that, as hypothesized, the oxygen that is a byproduct of photosynthesis is released more directly into the water by fully submerged plants because all of the oxygen that they produce goes to one place and one place only, being the water. The thing that is unexpected from this experiment was that the semi-aquatic and floating plants each had an average DO level of 5.34 ppm. This means that the differences between how much of the plants were submerged didn't have as much of an effect as was expected. There are also a few places where there may have been errors in this experiment. One of these comes from the way that the DO was tested. Since I was using a DO test that utilizes DO tablets, it leaves room for human error. If I misinterpreted what the color of the water was after adding the tablets, then it would skew the results. Through all of the plants, there was a range between 4 and 6 ppm. Even within each of the plants, there are differences in their results, such as the Lucky Bamboo, which had one trial that was 2 ppm less than the other 2 trials. These results may have been affected by external factors, such as whichever plants are more accustomed to the temperature that they were left in, or the amount of sunlight that they received being better suited for their environment. Conclusions. These results indicate that the best way to decrease the number of dead zones in the world once fertilizer levels have decreased is to increase the amount of true aquatic plants that are in recovering dead zones. This will make it so that they don't regress in their progress. This directly answers my research question by showing how the Cypris helferi, the true aquatic plants, had the highest average DO level. This also proved my hypothesis correct, as I believe that the fully submerged plants would have a higher average DO. These findings are important to the future. Knowing that these plants are more effective for creating DO in the shortest amount of time allows for us to assume that they would be the best plant for a recovering dead zone. By helping in the recovery of these dead zones, we can shorten the years that it would take for ecosystems to be revived. Not only that, but it's also important to the field of climate change research because a decrease in dead zones also means a decrease in climate change. This is an important thing now more than ever, making these results far-reaching. References. Here are the sources that helped me with my research.